Today's lesson is 9.3, Sketching the Graphs of Polynomials. So we're going to do a couple examples together, and then you should be able to do the rest on your own after we do just a couple together. So our directions say sketch the graph of each function, paying special attention to the zeros or roots. So these are synonymous, zeros and roots. Also, we could say x-intercepts. So we need to pay close attention to the x-intercepts, also the y-intercept, and the end behavior. So you should recall we can identify the end behavior for any polynomial function based on the coefficient and the degree of that lead term. So end behavior was 9.2. If you missed 9.2, you should go back and take notes on 9.2. So once we sketch these graphs, we have three things we need to state: the number of roots, the nature of the roots, and the name of the real roots. So let's take a look at number one. Number one says f of x equals x cubed minus 2x squared plus 4. For this lesson, we'll use Desmos.com. But before we actually graph this, we can actually answer that first question. A, the number of roots. So we can identify A, the number of roots, and that's equal to the degree of the polynomial. So since this polynomial is degree 3, we know that there are 3 roots. Next, the next question says the nature of the roots. So to determine the nature of the roots, we will need a graph. So I already have that graphed for you. So you can see here the graph of this function. Let's see here. Do you see it? Do you see it? There it is. Okay. So you can see that this graph hits in one spot on the x-axis at negative 1.13. And although there are 3 roots in this function, it only hits one time. So that has a couple of possible explanations, but in particular, since it actually crosses the x-axis at that one spot, we know that there is one real root at negative 1.13, so that actually goes into starting to answer our next question. So you can kind of answer B and C simultaneously here. So B, we have one real root. Also for part C, which asks us to name the real roots. So we said that root is at negative 1.13. And what's going on for those other 2 roots is that there are 2 imaginary roots. And so we can assume that there are 2 imaginary roots because this one real root, since there are 3 total, imaginary roots, the key to know about imaginary roots is they come in pairs. So let's go ahead now and sketch. So we have negative 1.13 right about here. We're supposed to pay attention to the y-intercept. So back to Desmos helping us out always. We can see the y-intercept here is right at 4, perfectly at 4. Now we have another dip right here. So it looks like it goes up, and then it comes back down right around 1.3 and then turns and goes back up. So the key points though are here, here. We could include this piece as well. End behavior though, kind of forgot to think about end behavior. End behavior, to review, is we can let's do one thing at a time. So we said that the y-intercept was at 4, 0, 4, and then there was a dip right at 1.3 right around here, and it went down to about 2.8 or so. So somewhere around here there was a dip. So we can kind of just sketch down and it bounces back up. The key points here are here and here, and then this end behavior. So this goes back to our 9.2 notes, where since our lead term is positive, it's a positive 1, and it has an odd degree, we know the end behavior is down on the left, up on the right. So we knew this before we, sorry I didn't have that in the viewing window. We knew that this was going to have down on the left, up on the right, and that's confirmed in our Desmos sketch. Okay, let's take a look at one more example. We have, let's do one. Yep, let's go ahead and do number 2. So number 2, let's skip to number 4. Number 4 says we have x to the 5th minus 2x cubed minus 1. And the first thing we need to identify is the number of roots. The number of roots here, since our degree is 5, is we have 5 roots. B, we need to identify how many, or what the nature of the roots is. Nature of the roots, meaning real or imaginary. So let's sketch this one here. So we have oh my goodness. Here we go, here we go. Back to our graph. There it is. Okay, so I'm going to graph x to the 5th, x raised to the, why does that always come up? Not sure. 5th power, stay away, we don't need you. Okay, x to the 5th. Let's come back to this one.